In this video, I'm going to teach you in detail about the power rule with rational exponents. So if we have a problem like this that says simplify, assume all variables are positive, and we have two quite complicated looking problems. And by the time we're done, you'll be an expert at how to do these, okay? So first thing, let's work on this one. We need to use the applicable exponent rules to help simplify. And these are the applicable exponent rules. These are all of them, okay? And we're going to go through and identify which ones we use for this. So we have, for this, we're going to use this rule, a combination of these two rules, okay? So we have an exponent out here, 3/4, that we need to multiply through into the rest of these exponents. And then we also have this situation where we multiply into each one of these. So it's a combination of both, okay? So over here, we have 16 just gets multiplied by 3/4. So we're using this property here, okay? And then we have y squared, and we multiply it by 3/4, and it becomes 6/4. So we are applying this rule here. And similarly, for the x squared in the denominator, when we multiply it by 3/4, this exponent becomes 6/4. Okay? So now we can use this property here for the 16 to the 3/4. Okay? So the 16 to the 3/4, we could rewrite it as this. So 4 to the square root of 2 and 2 to the quadruple power is actually equal to 16. So these two are going to cancel each other out. And then, of course, we have the cube root outside. Okay? So we use this property for the 16 to the 3/4. So when we calculate this out, it becomes 8, okay? Because these two are going to cancel, we're left with 2 here, and then 2 cubed is 8. So we have 8 times y to the 3/2 divided by x to the 3/2. So finally, we can simplify this even further because 3/2 is common to both of these variables. So we could just use this rule, and we could just say y over x 3 to the 2. And that's it. So now we'll go to this more complicated one. So we're going to apply this rule again. So it's a combination of this and this, because we're going to apply the 3 to all of these parts of the expression, okay? So when we take 3 and we take the power of 3, it becomes 27. Then x to the 4, we multiply 4 times 3, it becomes 12. And then y multiplied by 3 to the power of 1 here becomes 3. And then divided by, and we do something similar to the denominator. So 2 to the 3 becomes 8. X gets multiplied by the power of 3. Y to the 5/4 gets multiplied by the power of 3, and it becomes 15/4. Now we could use this to, because we have a division here, we can subtract some of these exponents where the base is the same. So how it'll look is like this. So we have 27/8, we just leave that the way it is. And then x to the 12 minus x over x to the 3 becomes x 12 minus 3, and then y becomes 3 minus 15/4. So now we can simplify this. 12 minus 3 becomes 9, and then 3 minus 15/4 is the same as 12/4 minus 15/4. So then when we simplify that, this is the expression we have. Y becomes y to the negative 3/4. And we can further simplify that, and it becomes 27x to the 9. 8 is in the denominator, and then y to the 3/4 is in the denominator, because y to the negative 3/4 means it just goes into the denominator and the exponent becomes positive. And that's it. That's all there is to those two problems. And don't worry if you don't understand that right away. You could just rewatch the video as well. Take a look at the description. There's a link there to my ebook that you could download. In the ebook, you'll find a link to this video, and you can follow along in the ebook as you watch the video. As well, in the description, you'll find links to other videos of mine that I've done that are similar. You could check those out. Thank you very much for listening, and please make sure to like and subscribe.